Welcome to the third video lecture series on Explainable AI. In this video tutorial, we are going to see about shape or SHAP. What is meant by SHAP means this is another explainability technique. In the last video, we have seen how to explain the predictions using line technique, local interpretable model agnostic explanation. In this video, we are going to see about SHAP. This is another important explainable technique. This is the base for all explainable AI technique. This is one of the famous technique also. Most of the research papers, they will use this SHAP models since its contribution towards explainability in prediction is very fabulous. And the name here itself, you can see Shapely, that is Shapely additive explanation. From this, I have highlighted this SH, A and P. From this only we have taken the word SHAP. So actually what is SHAP, why it is that much important, that all things we are going to see in this video. So basically this SHAP is a cooperative game model. So it is based on the cooperative game theory. Actually, this cooperative game theory is one of the famous theory that explain about, suppose I will tell one small thing. There are totally 11 players in a cricket game. There are totally 11 players playing the game. Sorry. Suppose the team wins the match. Then who is the most contributed player among 11? Suppose among 11 player, if one player is removed, then that team will win or not. He is a wicket keeper. If I remove that player and we have to check, if that wicket keeper is not there means, then the team will win the match or not. That is the contribution. So equal contribution, highest contribution to one person or other contributions are like that. What happens if individually how much contribution, combinedly how much contribution, so that the team effort makes the team to win. This is called as game theory. So what happen if one of the players are removed? Then what happened to the prediction? If the team will win or not? Suppose this player is present means the team will definitely win. Like that, there are so many debates will happen. So based on that, what is the contributing parameter or contributing player to move the fair distribution? So I want to divide the credits equally to all player means on what basis we will divide. These are all the things make the game theory more important in distributing the credits. Suppose here you can check this. Imagine a game played by a team of players. There are 11 players in a team. Assume that if a team win, who is responsible? Everyone try to take the credit since the game wins. Suppose if a team loses, no one will take the credit since I'm not responsible. I did everything, but the team loses. He is the responsible. He is the responsible. Like that, they will throw the what we call the loss reasons on other persons. The famous explanation is while going with our famous president, Dr. APJ Abdul Kalam, at the time of launching of that missile, what happened? Initially, the mission was failed. At that time, that scientists don't come forward to take the blame. At that time, what happened? Dr. APJ Abdul Kalam went forward and tell the loss is mine. I will bear everything. My scientists work well. I am the blamable person. Like that, he take the blame. Next time, the mission, what happened? It is successful. Then everyone come and ask, sir, you come and give the press note that the mission was successful. But what did Dr. APJ Abdul Kalam did? No, sir, you go. That scientist, he asked to you go and give the press meet and take the credit. That is the leadership quality what the person is having. That it does not come to everyone. So everyone want to take the credit of winning level. No one will come forward to take the lossage credits, bear the lossage credits. So this, in that manner, this cooperative game theory is designed such that no one can take the credit, no one will bear the loss. We will divide the credit into equally. What you did, what you did, what you did. On that basis, we will divide the credit so that credit distribution will be equal. And finally, we will find out who is the greatest contributor. So he will be awarded suitably in that manner. So there need a fair distribution among players. So that is why we are going for this game theory. For this concept only, it got Nobel Prize in statistics. So in statistical aspects, this game theory got one of the Nobel Prize winning concept. So here you can see player 1, player 2, player 11, all are in the subset. Once are in the set, one subset I am creating, that is called player 1. If only player 1 is present means, then what happened to the score? Player 1, player 2 present means what happened to the score? 9 players present means what happened to the score. If all the players present means what happened to the score. So we will get different weightage as per the line concept or previous concepts. We will get different weightage according to the player level contribution. That value are called as SHAP values. That value are called as SHAP values, and we are going to calculate the SHAP values, and on the average, if you find means, we will get the highest contributor responsible for predicting a certain parameter. So this is the concept what we are going to follow hereafter. So in the scenario of predicting heart disease, we are taking 3 parameters. You can imagine if you are not, this is the video you are straightly seeing means you can watch my video online. There we have created one small example, heart disease prediction based on age, BP and cholesterol. So here that age, BP and cholesterol are referred as players, 3 players. What are the different labels? Everything we are calling it as a players. And what is the final prediction means 68%. This person is having 68% of heart disease. This is the likely score. And that is also we are calling it as team score. So how much did each player contribute to attain this final score? See how 68% is attained. Who contributed high? Who contributed low to attain this 68%? That we are going to check. So the points distributed over entire label of the data set, that is called as SHAP value. So this is a global level. Global level means entire data set we are taking. We are not seeing the instances, we are seeing the labels. So what are the different features available in the data set and how each and every features are giving weightage to attain a certain prediction, that is called global level. So here we are not looking into how many patients are available, 1,000 patients or 1 lakh patients are, we are not bothering. We are looking only into the features of the data set. What are the different parameters? For example, here we are taking only age, BP, cholesterol, but different parameters are there. Bad cholesterol, total cholesterol. So all these players, there are 11, 12 parameters are there, means we have to assume that there are 12 players in a team. So that entire data set is common. It may differ from data set to data set. In what manner? Only the patients will differ, but the total attributes will always be same. That is predicted by the medical experts. That is framed by a medical experts. So we cannot change the features. So in that aspect only, SHAPE has a what we call very high prediction technique, explainable technique, since it is not looking into instances, it is looking into the features of the dataset. So in that aspect only, we are going to explain how important the SHAPE value are and how its contribution is in the explainable AI that we are going to follow now. I think everything is fine. This is a formula, basic formula. This is for a feature I. For example, for a single feature, this is the formula. So summation of S, a subset of N slash that instance into here you can see, yes, any subset of features not containing I. That particular I should not be present. For example, player 11 we are measuring means we have to calculate from player 1 to player 10. Player 11 should not be included. And then not of this set of all features minus yes minus 1. You can assume that one complete set, from that I am subtracting one number means you will get, without that player we will get entire thing. Entire set is there. From that I am removing player 11. So what is the thing I will get? So can you imagine what I am telling? So entire subset is there. Any subset of features not containing the feature. That is the with one I'm taking from the computation with the entire players, including everyone. So if I do that means what I will get? I will get the instance of the particular player 11 indirectly. That is what the magic of this formula. So f of s is nothing but model output using only features in the subset. What are the features available? And contribution of the feature. What is the total contribution of the feature? This formula, if we compute, means that become very difficult. So for understanding purpose, for UG student examination purpose, or for taking classes, if you explain this means you cannot complete it in 1 hour. So since it is to be computed by Python or some computational tools that you can do in a parallel manner. But for explaining this concept in a very funny and friendly manner, we are going to do some numerical computation based on certain aspects. Some of the formulas we will limit and restrict, but that is correct only. Same thing we are going to reflect. Let us check. So suppose the model predicts age is equal to 54, BP is equal to 130, cholesterol is equal to 240. This is the sample of the patient we are taking. We are not looking into the patient. So, suppose the model predicts only, I am telling, I am taking these values for these parameters, age, BP, and cholesterol. So these are the three players, and the prediction is 68 as per the old concept. Now here what we are going, let us check. If we remove age from the model, how much does the prediction change on average across all possible combination? That we are going to check. So f of age, comma, BP, comma, cholesterol is equal to this formula. Already you have to refer the previous lecture. Then only you can understand. Minus 233 is the base value. 3 is the weight for the age. 0.7 is the weight for the BP, and 0.2 is the weight for the cholesterol. So if you put all these things means I will get 68. Okay, so here how much contribution? This is for as per the single instance we are telling. If you remove that means what happened, that we are going to check now. This is total contribution. But if you remove one of the term, then what happened, that we are going to check. Here all are involved. Age, BP, cholesterol, all are involved. If I remove the age means what happened, that we are going to see now. So if you remove the age, how much does the prediction change on average across all possible combination, that we are going to check? This is what I have explained there. This is just for explanatory purpose. I am once again repeating. So correlation value is nothing but subset. That is V of S is nothing but different subsets we are going to create. That we will see in the next slide. You can see here V of phi is nothing but empty set. That is f of 0, 0, 0, which is nothing but my base value. That is nothing but minus 233. Next, what we are doing, V of age. Okay, so V of age is nothing but what is age? 54. Remaining two values are removed. Only age is present. Remaining two things I am removing. So what happened? Minus 233 plus contributing factor of the age is 162. Here it is available. You can see here. 162, that is 3 into 54. This is come from line theory only. Weight into the age. What age you are taking, that you have to take into consideration. Okay, automatically shape it will calculate. So minus 233 plus 62 is nothing but minus 71. Then what is the subset if I am considering only BP? So 0, 130, 0, minus 142. Similarly, cholesterol 0, 0, 240, this thing. So these values you are getting from previous. If I am adding weights means this value will come. You can see here This 3 into 54 is 162, 0.7 into 130 is 91, 0.2 into 240 is 48. This value is only I am using there. Okay, 162 plus 91 plus 48. So what is subset of age comma BP? If I consider these two things, 54 comma 130 means what you will do, minus 233 plus 162 plus 191. So it becomes 20. Age gamma cholesterol means very simple only. 54 0 240. So minus 233 plus 162 plus 48. This one. So minus 23. Similarly, these two things means minus 233 will be common. 91 plus 48 minus 94. If I consider total means you already know that it becomes 68 of the prediction. This is nothing but a prediction. So this, I think this computation is clear. These are creating the subsets. When only one player is present, when two player is present, when all the three players are present, what happens? Okay. Three features are there. So three, we are going to take the how many permutations will come. That is factorial. 3 factorial is equal to how much? 6 only. So 6 different combinations we can form. One combination we already know, age BP cholesterol. Next age cholesterol BP. Next BP age cholesterol, BP cholesterol age, cholesterol age BP, cholesterol BP age. Like that we can form different combs. Only for 3 features we are getting 6 permutations. That means if you are having 12 features means 12 factorial. How much will come, you imagine. So that becomes complicated. That's why these SHAP values are very important in doing complex manipulations. So here 6 permutations. We are taking all these 6 into consideration. Next, what we are doing, we are going to start this formula S is equal to 5 with V of 5 is equal to minus 33. Then add features. One by one we can features. Then you have to find the marginal contribution. You have to sum up all the things and you will get, and if you subtract means you will get the individual contribution. Already I told all the things. This is called enumeration of all the permutation layer by layer. Okay. So first permutation 1. What is permutation 1? H comma BP comma cholesterol I am taking into consideration. First S is equal to what? G 5 empty set. So V of 5 is equal to minus 233. So if I am adding age, what happened? Minus 71 will come. Where is how minus 71? Here you can get. This is minus 71. Only age parameter. Minus 71. Next for BP you imagine minus 142. At that time it become very simple. Minus 71 minus 233. Again you will get 162. Next, now age S is equal to age is equal to what? V is equal to minus 71. This will come into picture. Earlier empty set. Now this computation will come into picture. Now adding BP. BP is nothing but what? 20 minus 71. This will come. 20 is nothing but for BP value. Right. Here you can see BP is 20. Age and BP. First age is added and age and BP is added now. So what value you will have to take? 20. So what happened? This 20 minus of minus new value, that is 71. V is now become 71. So minus 71, this thing will come. So age we are considering. So I am taking V is equal to minus 71. If I add BP means BP value, age and BP value is 20. So 20 minus of minus 71, my contribution of 2 factors. So S is equal to how much? You will get V is equal to 20 again. This is, if you subtract means you will get 20. So if I am adding cholesterol means what happened? The 68 minus 20. So you will get 48. Okay. So this is clear. Now permutation 2. Age cholesterol BP. Now I am interchanging. So age is equal to this value, no change. Now cholesterol given age. Now I am adding cholesterol. Cholesterol if I am adding means what? Age comma cholesterol. Now you have to check age comma cholesterol here minus 23. Right? This is the map. You have to map this. So minus 23 minus new value 71. So what will be the value? 48 will come. And BP is nothing but what? 68 minus of minus 23, 92. So you can check the values. Everything is same. 162, 91, 48. Here also 162, 48, 91. Next permutation 3 is BP age cholesterol. I am shuffling this and this, but due to that also the value never change. Same permutation is coming. So BP is nothing but minus 142. Only BP minus of minus 233, that is 91. then age given BP, that is age comma BP if I consider means, here I am taking 20. Age comma BP, go and check there. Age comma BP is 20, right? So 20 minus of minus new value, that is 42, that is 162, and then finally 68 minus 20, that is constant, that is 48. Okay, so this is the thing you have to understand carefully. So 20 minus of minus this BP also 42, you have to first initially with the baseline, next with that value. That is what we are doing here continuously. Okay, so next you can see this is the 68 minus of this value, that is. Next permutation 4 you can try. Similarly, BP only minus 42 minus 233. This value plus BP, that is minus 94 minus of minus 142, which is equal to 48. Then 68 minus of minus 94, 162. Again, these orders will change, but all the values are same only. You can check permutation 5 also, same thing. Minus 185 minus of minus 233. Then minus 2 cholesterol if I add means minus 233 minus of minus 185, then 68 minus of minus 23. So these are all the different permutations. Similarly, permutation 6 also you can take. So all the values are same. Even though you are shuffling the contributions, this 6 permutation combination level, you are getting the same answers but in a zigzag manner. Now let us check what happened. SHAP values will be average of marginal contributions. So collect all the 6 permutation. What are the ages? You already see that in the all 6 permutation, age is 162 only. Even though the contributions are different, finally you are getting ages what 162. You can ask this will be happen, but this is the permutation what it is showing. So initially it is calculating BP and it is checking whether it is changing or not. So here you are getting 162 in the last term, but this age, but value will not change. That is, even though you are subtracting with different thing. Here you are getting 162 by subtracting 168 plus 194. Here we are doing the same thing but different combination, minus 23 minus 185. So that also age is the highest parameter. That is what we are focusing. Even though you are giving weightage to different factors also, the age contribution is not changing. That is what marginal contribution, that is who is leading, who is lagging, not a difference. But what is the contribution of age? That is what we are checking here. We are not considering about the players. We are contributing about contributions. What are the different contributions each and every players? That is, I am telling about player means, for example, here we are taking features into consideration. Which feature has highest order? That is what we are checking. So if I do this means what happened? This is 162. So contribution of age is equal to what? 6 into 162 divided by 6. This is the formula. So n in number of terms into 162 is the average divided by 6. So 162, similarly 91, similarly 48. Since value is not changing, same thing will come into picture. Okay. Now what happened? Shapely decomposition is like this. Minus 233 plus 162 plus 91 plus 48. If I add all these things, 68 will come. This is how the prediction happens. Same thing, but we are discussing in different aspect. So here you can see the reconstruction of the prediction. Base value is minus 233. Age is 162. How to read this is called SHAP waterfall diagram. How to read this, that is important. You have to know how it is telling. Here plus 162 they are putting, but you can see the value are not matching. You can see here some across minus 50 to minus 100 it is available, but in this 162 is not matching. Here also plus 91 they are giving, but here from some value it is there, somewhere there is minus 72, some 20 they are giving. So this is the thing we have to understand how this graph is created. That is the important thing. On what basis this 68 is attained? This is what the ultimate aim. Now what I am doing is I am going to explain this graph, that is minus 233 plus 162. If I add these two things, then what happened? Minus 233 plus 162. If I add these two things, earlier we have did this. Just I am going back for your understanding. minus 233 plus 162. What happened? Minus 71. This value. Okay, imagine here. Minus 71. So that is the graph. From this baseline, it goes up to minus 71. Initially, it is minus 233. Now, due to addition of this age, the value will increase and become what? One that is become up to minus 71. It is slowly increasing up to minus 71. Now the value base value become minus 71. After that, what we are doing? Minus 71 plus 91. We have to add that value. Minus 71 plus 91 means what you will get? 20. So from here to here, this is nothing but 20. Okay, so 20 plus 48. 20 plus 48 becomes what? 68. So like that, by adding different features, the prediction slowly improves and reaches 68. This is how the, not only by single value or nothing. These three are contributing back factors. Out of this, age contribution is very high. BP is contribution is somewhat less, medium, and cholesterol contribution is very somewhat. So this will be trained by the model again and again based on the age. If age contribution is very high, means automatically it will predict you will have this much percentage of heart disease. You can easily explain to others also. So initially minus 233, slowly it increases to plus 20 and increases to 68. This is how this entire shape value is working. So lime and shape are telling the same value. Prediction value is 68 percentage of heart disease we are having. So if you want, you can take this also. This is the interactive shape fall. If you, these are available here. So if I give means, okay. So it needs some internet also. I will check whether, yes, not available. Okay. So this thing you can uh, see by using the browser. If browser means you can check whatever I am telling, you can check there. But I don't know it is taking or not. Let us check once. I think it will not. This thing we can see, but okay, there is no time for this. So I will just, if this shape value waterfall coming means it will directly open in browser. So you can easily view. That is the point, but it is unfortunately it is not opening. So why I don't know. Maybe unsafe. Okay, this thing I will copy. Otherwise, then I'm pasting here. No point. Okay, this is not coming actually. Okay, I will give you in another aspect. So this is the thing how you are. I think you understand. If it is not understanding means I plan to do this, but it is understandable. So my initial base value will be minus 233. That is clear from 0 to minus 233. After that, with this, if you add plus 162 means the value boost up and stay at minus 71. Then if you add minus 71 plus 91 means you will get plus 20, that is the base level. Then plus 20 plus 48, this contribution factor, you will get 68. Like that only this, you have to read this sharp waterfall. So how it is increasing slowly and reaching the final prediction value, it will show. So these are all the things about SHAP method. So it is one of the most important method in the explainable AI. Most of the research papers are available based on this SHAP method only. So I think this numerical example will help you to reach out the SHAP in a better manner. Meanwhile, do the Python programming using this formula so that you will get the very accurate results on how many features you are handling, not an issue. Within a fraction of second, it will give you all the final results as per your computation. So this is the main theme what we are doing. So with that, I am completing the lecture of today. So if you feel any difficulties in doing this means you can just put your comments in the comment box so that I can able to answer you in a meaningful manner. Thank you for watching my video. Once again, we will go with some other concepts based on explainable AI, and we will explore what are all the different methods, how it is contributing. These all things we will explore in a one by one manner. Thank you all for watching this. Have a good day. Thank you.